This video is about extending the distance and midpoint formulas to 3 dimensions.
Okay, hi everybody. So in this little section here, we're going to be talking about coordinate geometry, but we're going to talk about it specifically in 3 dimensions. Okay, so we're going to have just a really brief introduction here to distance and midpoint in 3 dimensions. And when I say brief here, I mean really brief. I'm just going to kind of build this idea kind of quickly and just kind of give it to you. So just remember that in like a previous lesson here, you would have looked at the distance formula and the midpoint formula in 2 dimensions here. And here are the formulas that you would normally get. Okay? So you take a look at your distance formula, you've got 2 points here, x2, y2, x1, y1. Okay, and you set those, find the difference, square them, add them, let's take the square root, which looks remarkably like another theorem that you would have worked with a lot. Okay? Here, with the midpoint, you look at x2 plus x1 divided by 2, y2 plus y1 divided by 2. This is also an operation that you would have done quite a bit. Okay, now let's take a look back at a diagram here, and we'll talk about it a little bit. So consider that this line segment here, AB, okay, and we're going to come up with the length of this line segment and also the midpoint. So here are the coordinates here. A is negative 12, 6, B is 12, negative 4. Well, that first distance formula, looks an awful lot like the Pythagorean Theorem. Okay, so we're going to drop a line segment right here, and then we're going to have another line segment that goes across here so that this is a right angle, which is easy to do on the coordinate plane. And then we find that the difference here, the length of this is going to be y2 minus y1, just the difference in the y coordinates. This right here is going to be x2 minus x1, again the difference in the x coordinates, to get us those lengths there. And so then when we plug those in, that's exactly what we're doing. You just got to be mindful of the negatives, because they're important here, particularly when you're dealing on the coordinate plane. When something is in the negative part of the plane, whether it be like horizontally or vertically, I need to consider those negatives. They're going to impact my solution here, but in a proper way, okay? Not like as a mistake. They're supposed to do that. So we plug those things in here. So like, for example, 12 minus negative 12 means it's going to become 24. Add those together. When you square them, and away we go. We get 26. The midpoint, on the other hand, runs a little bit differently. What the midpoint is, it's really the average or the mean of the x coordinates, comma the y coordinates. Okay, so here are endpoints here. What we do here to figure out the midpoint is we basically take the average of the 2 x coordinates, so 12 plus negative 12 divided by 2. Now that in this case is going to be 0. Again, the negatives are important here. The y coordinates, negative 4 and 6, add them together, divide by 2. And in this case, we're going to get a midpoint here of 0, 1. So right there, make that bigger, that's our midpoint. And we know that that's going to be halfway in between. Okay. So now, to extend this into 3 dimensions is a really, really simple thing to do. I'm not really going to go and spend a lot of time explaining this. I might just do a quick little bit of a diagram just to illustrate, but you'll be able to follow along, actually, I think, fairly easily here. Whoops, wrong way. So just take a look at our formulas here. Notice that the distance formula, x2 minus x1, that's the same. y2 minus y1, that's the same. But now we've got this other term here, z2 minus z1. But it follows the same pattern beautifully. Additionally, the midpoint is the average of the x coordinates, the average of the y coordinates, and it's also now the average of the z coordinates. That's all we had to do. So now, when we've got 2 points, okay, now it's a little bit difficult to draw this, but kind of bear with me here. Okay, so this point here, negative 3, 6, 1, I'm going to assume that's like into the piece of paper here, where there's this point 5, negative 4, negative 3, considering the z-axis is running this way, is going to be out of the paper a little bit. For me to figure out the length between them, I'm going to use this altered form of the Pythagorean Theorem. Now, think about what this is doing here. Basically what we're going to do here is let's work in the x and y plane here to start off with. Okay, so the x and y here. So essentially what we're going to do is we're going to figure out the length to there. Okay, so it's going to be the difference in the y's, the difference in the x's, and that's going to give us this thing right here. Then what we're going to do is we're going to come along, this will be 90 degrees, and we're going to use the Pythagorean theorem again to figure out the hypotenuse here. Like we've got this side here, we already know this depth, okay, this is the difference in the z coordinates, okay, and then we're going to use that to find the hypotenuse. But this right here, okay, this right here is going to be the square root of the difference in the x coordinates plus the difference in the y coordinates. Now, square this, which just gets rid of the square root symbol, and add that to the difference in the z coordinates, and away you go. Okay, that's where this is coming from. So it's basically just the Pythagorean theorem applied twice, okay, once in the xy plane, and then once you've got that, really that hypotenuse of that triangle, I apply the difference in the z direction, okay, and to create a new triangle there. So anyway, in this case right here, it's the difference of the x coordinates, difference of the y coordinates, difference of the z coordinates. Plug that in, evaluate it, and then you go down as far as you can. Okay, and you should be simplifying the radicals. Personally, this is what I'm looking for. Okay, unless you're told to round it to a specific spot, I'd prefer that you left it in simplified radical form. When it comes to the midpoint, well, this one's even more straightforward. Okay, it's just going to be the average of the x's, the average of the y's, the average of the z's. We just plug those things in and evaluate, and we get this point 1, 1, negative 1. Now, again, just to state this again, I guess, and you're probably already aware of this, but just to kind of bring it to the forefront of your mind here, what this means is that the distance from M to A is the same as the difference from M to B. Now, I know that when we say midpoint, that's kind of implied by that, but sometimes that idea isn't the first thing in people's mind when they talk about the midpoint, so they're not seeing that that's a possibility as an application from that point on. Okay, anyway, now you should have enough to kind of do the exercises that we've got set aside for you for this particular topic.